In SPRT, to test h0, x following f of x comma theta naught versus h1, x following f of x comma theta 1, z is defined as log of f of x comma theta 1 divided by f of x comma theta naught, and h of theta is non-zero solution of expectation of e to the power z h theta is equals to 1. So under h0, the OC function L of theta becomes. So if we consider this h0, so h0 says x follows f of x comma theta naught, and h1 says x follows f of x comma theta 1. So if we define the likelihood ratio log of f of x comma theta 1 f of x comma theta naught, and h of theta is non-zero solution of this expectation of theta into expectation of e to the power z of z into h theta, which is equals to 1. So now, like if we consider this OC function, so operating characteristic function is defined as L of theta, which is probability of accepting this h0. So we know that under h0, so L of theta naught is nothing but probability of theta naught accepting this h0. And in SPRT, we have alpha is equals to probability of theta naught rejecting h0, and beta we have probability of theta 1 accepting h0. So this is our type 1 error, and this beta is nothing but our type 2 error. So we have like probability of theta naught accepting this h0 is nothing but 1 minus alpha. So if we consider this equation, the role of this equation, expectation of theta e to the power z h of theta is equals to 1. So basically this equation is used to derive the OC function analytically, like L of theta is equals to e to the power h of theta into a minus 1 by e to the power h of theta into a minus h of theta into b, where a comma b are this SPRT boundaries. But we don't need to compute this here because our question is asking specifically under h0 and the OC function at theta naught, which we already know by definition that it is nothing but 1 minus alpha. So therefore the answer will be 1 minus alpha.